Hello, everyone, and welcome to the Platformers weekly live stream. And today we are going to talk about a topic that very get me very excited on the last couple of weeks, and it's databases. And for us, you guys,
Databases? That's so
yeah, I know it's
exciting,
something.
guy.
I know it sound boring for some people, but I know something catches me with databases because it actually runs on every system, and it's a critical component. Like there is no system without a database.
I totally agree with you. One could even say that every application is basically just the front end for its data on the database. Whether it's the front end or the back end, it's all just front end for data.
That's true. I cannot argue with that.
It's pretty
So
hard to argue with that.
it's hard. It's hard. But there is no reason to have a database without a system or a really good use case, right? And today we are going to talk about database use cases.
Indeed, indeed. We're not going to dive directly into databases specifically, although trust me, Guy, we could do that together for hours and hours. But we're going to talk about something that you use the data on databases for, which is search and how to construct and what types of search methodologies you can use when you're building good search into your infrastructure.
I'm in. I'm in. But before that, I cannot let people join to the stream without introducing you. I want them to know you. So today we got a special guest and a database expert, and this is Ben Greenberg from Couchbase. I'm very excited about this stream. I think we talked about for the first time in September, maybe before that, and I'm very excited that it's going to happen today.
Same. It's been a long time we've been talking about this. I feel like it was last year. We started talking about this last year.
Last year, yeah. It was a long time ago. Who can remember when it was?
I haven't seen you
Exactly.
since last year, Guy. It's been so long.
physically, physically.
Yeah, exactly. Exactly.
So maybe without further ado, we can jump into databases and search.
I love it. Yeah, let's do it.
Cool. So I'm just. Woo. So just for the people watching us, just before we are starting, uh, if you have any questions, note something that you don't understand, feel free to comment like every stream on. If you are on YouTube, you can comment on the video, and if you're on LinkedIn, comment on LinkedIn. And what we will do is that after the session, we will have some time for Q&A. So feel free to ask the questions all along the session, and we promise that if we will have time at the end of the session, we will review your question and answer them, hopefully.
Hopefully. Hopefully. Sometimes an answer is, I don't know, but I'll get back to you. But that's also a good answer
This is a
sometimes.
good answer. This is a good answer. I
It
love
is.
those. If you
It's
get
better
back
than
after.
let's make up an answer on the spot and hope it's true.
Absolutely. We don't like false answers.
No, definitely not. Definitely not. Okay, I think let's get started, yeah?
Yeah, let's go.
Okay, let's go. So, my friends, today we're going to talk about, I think, something that we all take for granted quite a lot. And we do it as users of applications, or we do it as we are thinking about the infrastructure of our applications, or if we're building the functionality ourselves for those applications, or if we're somewhere in between, we're doing infrastructure and we're also building out the functionality. We often have to think about search, right? Either performing search, creating good search, thinking about the parameters of search, and what type of methodology of search to employ and to use, because search is a lot more than just typing in something in a search query in a search box, pressing enter, and then voila, we have results. I mean, that's like what we want our users to feel like, but there's a lot more that goes behind search and goes into search than just that. And so in order to fully understand this, we need to take a journey. And our journey is going to take us into the mighty wilderness. You know, we're in January. It's pretty cold outside, and it's actually in my view, it's freezing outside. But that's a whole nother conversation. It's absolutely freezing, and you want to understand a really fundamentally important question: is winter coming? That's a really fundamentally important question to want to know. Is winter coming? But in our context, we don't just happen to live anywhere. We live in the kingdom of Westeros. And in the kingdom of Westeros, in the world of Game of Thrones, is winter coming doesn't just mean, hey, do I need to put on a nice jacket today and bundle up before I go outside? Winter coming in the world of Game of Thrones means a lot more. It means something like, I got to prepare for battle. It means the demons are coming. It means they're going to breach the wall. And so, if I want to understand is winter coming and I want to understand what that means for me as a person in Westeros, how do I find out? Well, I'm a good citizen of Westeros. I'm a digital native. I'm going to go on the internet and I'm going to search for my query, is winter coming? Now, when I search for my query, is winter coming? And let's say I'm Jon Snow, what does Jon Snow want to know when he asks that question? Does he want to know if he needs a big coat on? Or does he want to know if he needs to prepare for the demons? Right? That's the question. And will the search understand what he wants to know? If you think for a second, you go to any of your favorite search engines, although oftentimes it feels like you only have one out in the world. Go to your favorite search engine and you type in, is winter coming? Do you think you're going to get information related to your specific context? If you're living in Westeros, or you're living in Miami, or you're living in Tel Aviv, or you're living anywhere, or are you going to get just generic weather reports? That's really the question that is at the heart of our conversation today. And how do you build search that understands a bit more about your users? Because the stakes are pretty big. You know, when I'm old enough to remember when Google started, right? That places me, I could retire soon, I know. But I'm old enough to remember when Google started. And I remember searching on Google for the first time, and it felt amazing. Before Google, we had things like Alta Vista, Ask Jeeves. I remember Ask Jeeves for a bit. I don't know if Guy remembers Ask Jeeves. Alta Vista was very popular for a very long time. And that was good, but Google felt like just a step above in its ability to really give me what I wanted. But at some point, this is a great article from a couple years ago now, because we're in 2025, from the Atlantic magazine, that Google now just feels like, I actually just fell for this today, by the way. I was giving a presentation at my company office to my colleagues, and I just wanted to search for something quickly on Google to show them like another product page. And I typed in the product name of the company, and I clicked the first link, and it wasn't the company that I was searching for. It was like a company that bought the SEO search terms for that
Oh,
company. And I just searched. Well, I guess I cost them some money because they had to pay for that, right? But like the actual company I was searching for was like result number 7 on the list of Google search
oh,
results.
wow.
And
Wow.
that's like, and this, by the way, Guy, without mentioning company names, is a very big company in our space. And it's like way down there in the list of Google search results. But that's kind of like what it's come to. Search feels often very broken. So in our time together, we're going to talk about, first of all, why should you care about this at all? And I'm going to answer that question really briefly. Then we're going to look at the different forms of search: keyword, semantic, vector, and hybrid search, and when to use each of these. And I'm going to run through with you very quickly just some really quick do's and don'ts when you're implementing with these search methodologies. So if you understand keyword search, amazing. But if you always wondered, hey, what is this thing I'm hearing about nowadays, like vector search, and what is a hybrid search? Well, my friends, this talk is for you. You are in the right place today. So no matter if you are an SRE or a developer, or a developer slash SRE slash SEO optimizer slash put out fires person slash everything, I hope you'll get something out of our time together. And yes, there's gonna be a lot of Game of Thrones references, because how could there not be? We have to have references to some fun stuff. Okay, so first of all, why do you even care about this? So I'm going to tell you care about this because somebody on your team in your leadership is going to give you a ticket someday related to search. And you're going to come to work on the first day of the week. You're going to open up Jira, and you're going to find, maybe if you're a developer, you're going to find a new Jira ticket that says add a search function to the website. When it should be done? Now, yesterday. What are the requirements for the search function? It should work. And that's it. That's gonna be the whole ticket. And if you are on the DevOps side of things, you're gonna have a ticket like you need to incorporate search functionality in the architecture of the site. You need to manage the data, the load, the capacity, whatever. You're gonna have some search related questions, some search related tickets are gonna appear. If they haven't appeared yet, they're at some point going to appear. And the more you understand what you're dealing with, just the better you will be in place to do the work, right? Like the more you have a grasp over the fundamentals, the better it will be for all of us in being able to implement on whatever place in that spectrum we are implementing. And when you are implementing, the things you need to think about are things like, what are the performance requirements for the search? What's the context of the search? What's the use case I'm building for in my application? What's the nature of the data that's being searched? What's the structure of the data? What type of data am I searching? Am I searching text? Am I searching images? Am I searching audio? Am I searching video? Am I searching a combination of those? Is the data structured? Is the data unstructured? Is the data validated? What's the data type? And then ultimately, of course, what problem is search solving for my users? Depending on whether it's an internal use case or an external use case, maybe you're building search functionality to search across a knowledge base for a customer support team in your company, or maybe you're building a search functionality on an e-commerce shopping site. Those are different problems that you're solving for different types of people. So understanding those and understanding these questions amongst other questions will help make you better informed as you're building your search functionality. So that's why it's important. Even if you are literally today not building search, amazing. That's brilliant. But understanding these things will just make you a better, more informed person. So when the time comes, you'll have more data and be able to approach it from a more holistic perspective. So now that we have a sense of why it matters, which is a big question, and I hope I've convinced you at least a little bit that understanding these things matter, what are the different types of search? So let's start from the one that probably all of us in this conversation together are probably familiar with. I would imagine every single one of us here has either used, probably today many times, probably yesterday, probably in the evening, probably all the time, keyword search, which is, what is keyword search? Let's take our example of Jon Snow searching for winter in Westeros. So he's going to search in Google, is winter coming? Keyword search is exactly what it sounds like. We're going to match the words in the query to the words in our data set. That's keyword search. It doesn't seem very complex because it's not very complex. And essentially, we take the words of the search and we tokenize each word. What does that mean? Each word in the search becomes its own unique basic data point, a token. And that the data set, in this case, let's say we have a very simple data set. Let's say we only have 2 documents in our data set. One of them is a document that says winter is coming to Westeros. That's one data set. The other one is a winter clothing sale is coming, right? So we have 2 pieces of data in our data set on our application. Winter is coming to Westeros and a winter clothing sale is coming. And Jon Snow searches, is winter coming? So we've tokenized the data in our data set. We've tokenized the query. And what happens is we split those individual words into tokens from the query. We calculate a relevance score based on how many tokens match the query to the data sets. And then we iterate over the documents and return the highest scoring documents from that search. That's a keyword search. And there you see an example on your right-hand side of a basic implementation of that in JavaScript, everyone's favorite language, of course, in JavaScript. And so what happens then is if we do a keyword search on those 2 data sets, winter clothing sales coming, winter is coming to Westeros with is winter coming as the query, they both return a score of 1. What does that mean, Guy? It means that they both return a score of 100% relevancy. The winter clothing sale is coming, and there is a winter is coming to the kingdom of Westeros, are both equally relevant to the search of Jon Snow in a keyword search. That's a little wild.
That's bad because I don't want clothing. I want to watch TV and understand when the war is coming.
Right. You don't care about a clothing sale. So that means Jon Snow's search results are going to be intermingled with relevant and not relevant data equally. That's not helpful for Jon
Yeah,
Snow. That doesn't let
yeah,
Jon Snow prepare for what he needs to prepare for. Not good.
and absolutely. And I think something that I always like when I search in Google, this is what I do behind the scenes. Like I think on keywords always. Like this is
That's
how
right.
my brain is structured. I know.
Because it was also the first search. Search was built around keyword search because if you think about it, it's the easiest to implement and it just makes the most intuitive sense from the beginning. I want to search for the words that are in my search question, my search query, against the words in my data. That just makes sense. But it clearly doesn't meet the needs of many use cases at all.
Wow.
So
So
that
what
takes
can you
us, of
do?
course, so it takes us, of course, to our next one, which is understanding semantic search. Now, some of you may have heard of this term semantic search, or of these words semantic search. If you have, that's brilliant. Semantic search takes us a notch above keyword search. So let's take our example again. Jon Snow is searching for is winter coming? Big question. In semantic search, we're going to utilize NLP and context understanding to interpret the query. So, what is NLP? Natural language processing. NLP has been around for a very long time. NLP is essentially training machines to understand the nuances of human language, right? Understanding how we speak and understanding the way we speak. It's actually very challenging. It's challenging based on which language, human language you're talking about. English is structured very differently than, let's say, Arabic. It's understanding sarcasm. It's understanding gender in human language. Like some languages are gendered, i.e., like a table can be a male or female item in many languages. In other languages, there is no gender in the language. Understanding all of these things is super complex. And we've been working on this, and by we, I mean the world of people, NLP researchers and practitioners, not me personally, have been working on this for decades on natural language processing and implementing this in programs and in machines to understand them. So semantic search would be taking the query and understanding the words itself from a perspective of human language and the context of the search. So when we look at the query, is winter coming? We see two key words in that query, right? Is, of course, is not the key word. Winter and coming, right? And winter refers to cold and a season in the annual season of seasons, right? So unless you were born and raised like I was in California, where we only have 2 seasons, many parts of the world have 4 seasons, and one of those seasons is called winter, and it's a season, right? And the word coming it relates to arriving or approaching. So the query from an NLP perspective is asking, is winter season approaching? Is the cold season arriving? Like that's the interpretation from human language of that question. And then in the context of the data, well, we have two contexts in our data. We have winter is coming to Westeros, and we have winter clothing sales coming. One is related to a TV show, or I guess in Jon Snow's reality, the reality of his life. And the other one is related to the seasonal context of winter, that you have clothing related to a cold season, and there's a sale for it. So we understand first the semantic analysis and then the context recognition. And the way one might build that in JavaScript is we basically would take the query, run it through different scoring mechanisms with NLP techniques, analyze the semantic similarity, get a relevant score based on the semantic similarity, return the highest scoring documents based on that semantic similarity, and then order them in descending order, right? That'd be a nice implementation of it. And what you would get back from doing that is you would get winter is coming to Westeros would score 100%. Winter clothing
Wow.
sales coming would score 67%. That's a lot better, right?
Yeah.
Because what I'm getting now is I'm going to have some clothing sale data in my return results, but it's not going to be equally intermingled with Westeros data. It's going to be a little less. Maybe it'll be result number 4 and 5, but the first 3 results are going to be things that are really important to me as Jon Snow. I'm going to get the data that's really important. And maybe Jon Snow's also cold and he does want a jacket. So by reserve number 4, he gets a sale from some coat factory and he can order a coat. It's amazing. So he gets everything he needs. So that's essentially semantic search. So semantic search is really good at understanding the context of the and intent behind the queries, which makes it excellent for nuanced searches. Semantic search is awesome. Which leads us to vector search. Vector search is employing semantic search. And you're like, wait, Ben, what? Semantic search, vector search is employing semantic search. It's about how it's done that's different. And it's semantic search plus. So let's talk about that.
Oh.
And caveat, vector search is a lot. And what we're going to cover in the next few slides is only a brief touch point on it. I'm actually just finished a draft on the topic of vector search for developers, a new book, hopefully coming out this quarter.
Wow.
I would recommend you buy my book, not just because I want you to buy my book, but also because it'll be really helpful for you coming down the line to dive deep into vector search. So we're just going to cover some of the basics here, but you can find that book hopefully this quarter, sometime in Q1 of 2025, published by the Pragmatic Programmers, a really good programming bookshelf publishing house, pragprog.com, vector search for developers. Okay, so that's just like
Amazing.
a caveat. We're only going to cover the basics here.
Just before we are going to the next topic, when the book is released, we will post it on LinkedIn. So follow, and we will make sure that you will get a post about the book.
Get a post about the book, and I may even include a coupon code for the platformers, so you can get a discount on the book.
Oh,
even
that's awesome.
better.
That's awesome.
Okay, so we're back to our winter is coming, right? So this is our query. We're running it through different mechanisms. Is winter coming? We're going to run it through vector search. Vector search uses what we basically arrays of numbers, mathematical representations, which are called vectors. A vector is nothing more than a list or an array of numbers. And those numbers, though, each number in that array, in that list, represents the relationships between words in the data you have. Both the semantic relationships, the contextual relationships, the relationships of capturing all the different dimensions of that data in numbers in an array. So, for example, you could have that every data is represented by something like 1,536 dimensions in a list. And each dimension is a different aspect of capturing something about that data. So 1,500 different ways of understanding that data. And so that's a lot, right? And that includes semantic. It also includes the relationships between the data items. So the way this may work is you have your question, is winter coming? You take the query and you embed that into a vector list itself. And there's different models to do this, different ways to do this. You could do it with models from like OpenAI, from Claude, from Perplexity. You could do it with models that are free and open source in your own machine. There's all ways of doing this. As long as the embedding you've created for the search is the same model you've used to create the embeddings for your data. That's very important, right? So if you can't use an embedding model, let's say you use GPT for your query, but you use something else for your data, well, they're not going to be able to search across each other because they're not going to understand each other. You have to make sure you use, and not only GPT, but let's say you use GPT Text Small 3, which is one of the OpenAI models for the query, but you use embedding ADA002, which is another model from OpenAI for the data. It's also not going to understand each other. You have to make sure you're using the exact same model across both the search term and the query. And then you now take those two and you take the search term and you search for similarities across your vectors representing your data. The lists of numbers, your vectors representing your data, and you compute the similarity score. Now, there's many different ways to compute the similarity or how close the data set, the numbers representing your searches to how close it is to the data in your data set. That's the closeness scoring. There's many different ones. You can use something like cosine, which, and now we're getting to like things like math, and math is totally scary, but we're getting to things like cosine similarity, or the Manhattan product similarity. Sorry, not Manhattan distance similarity, or the dot product similarity scoring. And without getting into the details for now, because that's way too much for this conversation, but each one of them is a different mathematical formula to understand how close one vector is to another vector. That's all you're basically doing. So you have your data, and remember, our data is winter coming. Winter is coming to Westeros, and a winter clothing sale is coming. Each one of those would be then converted to a list of numbers representing all the different relationships, semantic, contextual, et cetera, et cetera. And then you have your search term, is winter coming? You would try and find in your search, you would try and find in your data the closest matching vectors. Right. So here's a very, very simplified form of that. Right. You have your search, is winter coming. Not winter is coming, but is winter coming. And each of those dots represents a vector. Right. And let's say the vectors over in that one we've highlighted are as data related to the Game of Thrones. Right. And those are the ones that you're going to return back to the user. And the ones up in the far left quadrant, let's say, are related to clothing sales. And the one in the far right are related to, in the far right quadrant, are related to weather conditions in Anchorage, Alaska. You're not going to return the ones on Anchorage, Alaska. And the one on the upper right are related to historical patterns of weather for dinosaurs during the one of the dinosaur ages. Also not going to return it. But given understanding the different understanding, because the dimensionality of the data, and understanding that it's capturing the context, the semantic understanding your user preferences, all the sorts of things that you're embedding in those vectors, you come to get more accurate result. So in our context, because all we're doing is just a search we don't know the user, we don't understand what their preferences are, we haven't captured any of those things in our embedding, we're going to get back scores very similar to our keyword search. We're going to get back 99% relevancy for Westeros, and 89% relevancy for clothing sale. And I intentionally built it up as if this is going to be the solution. But it's not necessarily the solution. It depends what is embedded in those vectors. What kind of data is embedded to give us a better result? If we don't know anything about the user except for that search term, we don't know anything about the data except for the data that is just those two text terms, that doesn't mean vector search is going to be automatically your best approach. And I find this to be something very common nowadays when people are asked to implement a search in their applications by managers or by whatever. Oftentimes nowadays, because of the popularity of vector search, they reach for it first. But just because something is popular doesn't necessarily mean it's the best approach always. Which leads us to the next part of our conversation. So first of all, before we get there, just in case it wasn't clear, semantic search is understanding the meaning and intent with natural language processing. Vector search is capturing the relationships between entities, including the semantic context, but not only, right? Capturing it mathematically in those numerical representations, in those arrays of data we call vectors. Which leads us to what I think is often sometimes the best approach for our applications, which is a hybrid form of search. Hybrid, of course, is more complex, but it's going to give us sometimes better results. So is winter coming? Hybrid search would utilize keyword matching, semantic analysis, and vector search to provide the best relevant and similar search results for a user. So we would match on keywords, we would use vector search, we would compute similarity, including the semantic similarity, and come back with a contextual understanding as well, and give back the best score. So in this case, if we're using semantic search, we using hybrid search, I should say, depending on the way we formulated it, we can come back to a result that gives us much closer approximation to what the user in our case wants, which is Westeros data is scoring 95%, and clothing sale is going to score 72%. Is it perfect? No. But is it much better to what we want? Yes. And really what it comes down to is calculating when in our hybrid search implementation, when to use which one for what type of search. And when to employ which one is really some conditional logic we need to understand when we have the right data, what type of search to use, etc. And so hybrid search combines keyword matching and semantic analysis with vectorization to provide precise, contextually relevant, and semantically similar search results. Now that we have a sense of understanding the different types of search, the big question, and I laid it up for us by kind of like putting up vector search as the savior, as the solution, as the messiah, when it's not always the solution. And so when to use each type of search is really going to be, I think, the ultimate decider of whether you built something effectively or if you haven't built it as effectively as you could. So keyword search is great when you have straightforward questions, straightforward queries, and high precision on exact matches, simple implementations. And remember, keyword search is often from an infrastructure perspective going to cost less. It's going to cost less both from a computational perspective, it's cost less in compute time, and it's also going to cost less money-wise. It's cheaper. It requires less work, less compute time equals less money, right? It's just cheaper all around. So if money's a factor as well, it's a huge motivator. Best example for keyword search, most simplest example, when somebody's literally searching by a SKU. So, your product SKUs like 003598134567 and the user is searching for that SKU. Do you need semantic search for searching by a SKU? No, you don't. You're literally searching for a product identifier. It's exact, right? Semantic search, on the other hand, is really good when you need to match with human language. So when someone's searching with questions or searching with the words that they normally use, and the context and the intention are really relevant. And when those contexts, you need to handle things like linguistic challenges. Humans speak really weirdly. We don't speak well, and we don't handle words well. Wars have been started because people just can't get their words right? Like we just don't know how to talk. Families have major fights for years because they misspoke. So you need to handle things like synonymy and polysemy, which are just a tip of the iceberg of grammatical, linguistic, human language issues that semantic search helps handle for you. Synonymy, in case you're not familiar with linguistics, synonymy is when words have similar meanings, but they're different words. So like small and little, big and large. They're the exact same thing, but they're different words, right? So you need to handle that. Or polysemy is when the same word has different meanings or related meanings. So if I'm saying get, the word get in English, that can mean I'm receiving something, or it can mean I'm going to move something somewhere else. I'm going to get this and put it here. Or I'm getting this, you're giving me something. I'm moving something somewhere, or I'm receiving something. It's the exact same word. Depends maybe on the conjugation. Is it a verb? Is it an adverb? Is it how am I using it? Right? And there, the context really matters. So semantic search is really, really good at that. And of course, a great example of when semantic search is awesome is a FAQ, or a frequently asked questions page. Someone's going to search on an FAQ. Why is this not working? I have tried this for 2 hours and it's failing. This method I'm trying to implement it, I'm getting a no method error, or it's returning undefined. They're searching with words, and you need to handle those words. If you would just use a keyword match on that kind of search, you're going to make that frustrated user even more frustrated by default. Vector search, on the other hand, is excellent when you're trying to find similar content. recommendations based on similarity, and handling complex relationships between data. Really, really good at that. And a great example of that would be one of our most popular places to spend our time and not do anything for hours, Netflix, right? So anytime maybe you just binge watched the Great British Bake Off for like, 2 days. You sat on your couch the whole weekend, you just watched British Bake Off. And suddenly your Netflix recommendations are all about now watch the Italian cook off and watch the Portuguese, barbecue show and watch the French cigarette smoking hour. And like suddenly you're just like getting all these content recommendations based on similarity to what you just watched. My friends, that's a form of vector search that you're experiencing right there. Your data, your watching habits have been vectorized. Lo and behold, you are a vector. You live as a vector in Netflix, basically. That's essentially what's happened. Hybrid search is when you have a site that needs to manage all these different types of things. And you need to balance your cost with your accuracy, your compute cost with your accuracy. What's a fantastic example of a hybrid search platform? You probably have used it maybe in the past few weeks. Maybe not today, but in the past few weeks. Any kind of e-commerce shopping site, Amazon.com, any of them. Sometimes you're searching on Amazon for an exact product name. Sometimes you're searching on Amazon for a category. Sometimes you're searching on Amazon for a product ID. And Amazon has to know which search you're doing and how to return the data that feels most relevant. And Amazon's not alone in needing to do that. All commerce shopping sites need to do that. Do they all do it well? No. Does Amazon do it well all the time? No. But they all need to do it. And it's a constant struggle of balancing the different types of search and understanding users' search patterns to employ which search for which type of search query. So e-commerce shopping sites. So keyword search is great for product codes, exact titles, semantic search for customer support queries, ambiguous meanings, vector search for similar types of documents, image search, fraud detection, by the way. We didn't even talk about that. It's a great use case. What is a use case of fraud detection, by the way, with vector search? Imagine all of your transactions on your credit card that you make are vectorized. Every transaction. And those transactions are vectorized, including dimensionality of like the dimensions include the locations of where you've done the transactions, the categories of the transactions, the times of day you've done transactions, the et cetera, et cetera. And now every new transaction is compared to that vector of your previous transactions. What happens when something you do is out of the pattern, doesn't fit in closeness, it's very far away from your transaction vectors? It's going to alert your bank that maybe there's an issue. You know who uses this? Revolut. It's a big British bank. They have built a vector search system for fraud detection that searches within milliseconds for every transaction for all 12 million customers.
Wow.
That's pretty incredible. That's pretty incredible. And I have to say that they built that on top of Couchbase. I have to say that. Just have to get that in there. They built it on top of Couchbase. Pretty cool. And hybrid search is great for anything where the search patterns are different at all times. So you may have searches of different types, e-commerce platforms, job searches, health information systems, like you're searching on your HMO for your medical data, all different types of search where you may be searching in different ways. Sometimes exact matches, sometimes semantic matches, sometimes content similarity matches. You need to factor for all of them. Okay, let's cover some quick tips on do's and don'ts in when you're implementing these things. You should do these things and you should definitely not do some of these things, okay? So when it comes to keyword searching, you need to index your data. Very, very important. Build search indexes, whether you're using structured data like in a Postgres database or unstructured data in like a NoSQL database. Make sure to index. Search indexes are your friends. Make sure to sanitize your input for casing, because you'll be surprised in 2025 now, there are still search systems that are case sensitive, which is wild to me. And this is also wild. There are still websites out there that are not sanitized for SQL injection. My friends, Don't let somebody drop your database tables in your search bars. It is really, really important. And also, to save you on your compute time, linguistics linguistics is your friend, even if you're not a linguist. Stemming means reducing a word to its root, running to run. Lemmatization means reducing a word to its basic form, the word better to good. Why does this matter? Sometimes people like to use big fancy words when they're searching for things, big multi-syllabic character words. Those are more expensive. Reduce it down to just the simplest form. Saves you time, saves you money. Don't worry about altering a person's search when you're doing it intelligently. Do worry about it when you're not doing intelligently. But reducing a person's search to its basic word forms saves, and if you do it at scale, does actually save you some money. Don't rely on keyword search for complex queries. Don't neglect performance optimizations for large data sets. Don't ignore stop words without considering the context. So people often, this is the unintelligent versus intelligent modifying search terms or search queries. Things like the, and, it, not it, the, and words that you typically like you can drop are called stop words, right? But sometimes those words, the word or, sometimes those words do matter, sometimes they don't matter. Understanding when they do matter, when they don't matter. For semantic search, don't try and build your own models. Use pre-trained models. Understand which ones are the best. Do use recognition of synonyms and always fine-tune your models. So get user feedback on performance and always fine-tune your models. Don't rely solely on semantic search for highly specific queries. And don't forget things like ambiguous words and polysemy, which we covered earlier. With vector search, utilize dimensionality reduction to improve performance. Those are a lot of big words. Let's actually break down what that means. Dimensionality reduction. So we talked about how a vector will contain many dimensions on the data, sometimes 1,500 dimensions, sometimes 2,000 dimensions. You may not need all of those dimensions, and there are tools built into these embedding models, tools built into the actual things you're going to use that can reduce the dimensions down to, let's say, 800 dimensions. That matters, right? The less dimensions you're searching across, the faster the thing will be. You don't want to remove dimensionality of dimensions that matter, but you do want to understand what is being embedded and how you can reduce them. And of course, if your data is getting updated, your vectors need to be updated also, right? So if you have an entirely new data set and you haven't updated your vectors, your users in a vector search are searching your old data. So you need to make new vectors every time you make meaningful changes to your data. Keyword there, meaningful changes, right? You need to understand what is it, because making vectors is also expensive. You understand what is a meaningful change, what is not a meaningful change. You need to be able to factor that in as well. Don't ignore scalability for storage and compute. And you need to really make sure you're using a specialized database for vectors. Vectors are huge. They take up a lot of space. They can be really slow. I don't care if you're using a NoSQL database, a SQL database, although I would say that unstructured NoSQL databases are more naturally inclined to vector databases than SQL databases. But whatever you're using, please make sure you've optimized it for vectors, because you will thank yourself later, let's say, once you start scaling by doing so. If you don't do that, and you don't need to invent the wheel, my friends. You just need to search and find the right vector databases. They're there for you. You don't need to create it. It exists. The platforms exist. Just use a vector database. For vectors, don't try and stuff vectors into a non-vector optimized database. With a hybrid search, what really comes down to is adjusting the weighting of the different search components, understanding which search technique is best for which use case, and weighting it appropriately in your infrastructure. So that means you need to get feedback regularly from your users, how the search performed for them, because your best source of testing there is going to be in production. It's going to be a user feedback. It's going to be users telling you whether this was a good search experience or not a good search experience, and using that data to optimize and make it better. So having said all of that, at the end, Guy, I'm happy to tell you that you now know how to do search. You are an expert in search.
I'm so, yeah. I feel so lucky. Yeah.
You should, but I don't mean to also burst your bubble, because search is really good. And you may think to yourself, I didn't really know everything, but knowledge is power. And the more you can learn, the more you can build, the better it'll be for you. And this is really just the beginning of the journey. You're not an expert in search at this point. None of us are experts, but I hope that this time together covered a lot of the basics and gives you a lot more to think about to move forward into whether you're implementing it from a code perspective or from an infrastructure perspective. You feel more empowered in the conversation.
Absolutely, and thank you for the use cases and the tips. So I know where is the right time to use what type of search, and how can we architect that to work on scale. So Ben, thank you very much for joining us, and thank you for the intro, but also deep dive into vector and search in general. And for
Awesome.
everyone watching, join us next week. See you around.
Thank you.
Thank you, Ben. Bye bye.